Alright, so we're going to be talking about arithmetic and geometric sequences. So first let's take a look at arithmetic sequences. Arithmetic sequences. This might be the easiest to identify since they are just adding and subtracting a number over and over again. So I'm not going to go over what a sequence is. You should already know what a sequence is. It's just a series of numbers. There's a sequence to it. So arithmetic sequences, I do want to go over what these elements represent. So a sub n, it's pretty much the number you're looking for, or you might be looking for. A sub 1, because of this little 1, that represents the first number of the sequence. N will also represent the number that we're looking for, and D represents the common difference. So the common difference is pretty much the number that you're adding over and over again. Also, in case if you don't know, there's a different way to write this equation, and that's would be a sub 1 plus D times n minus 1. So pretty much all I did was take the D and put it on the other side of the parentheses. So this form of writing it, it's the same thing as writing it in this form. So that's the equation, and that's pretty much all the values of on the equation. So an example of this would be like, what is the 32nd and the 14th term of the following sequence? So we got this sequence. First thing to do, we have to identify what is the first value. We also have to identify the number that we're looking for and identify the common difference. Three different things. First value, the first value it's going to be 1. We're looking for the 32nd and the 14th value. So again, we have the first value, we got which would be a sub 1. We got the D value, which would be either the 32nd or the 14th, depending which one you want to do first. But the one thing that we need is the common difference, D. So what is the value that you're adding every time to get to the following number? So what plus 1 will give you 5. What plus 5 will give you 9. What plus 9 will give you 13. That's pretty much the question. And we can pretty much notice that D will have to be equals to 4. 4 plus 1, 5. 5 plus 4, 9. 9 plus 4, 13. 13 plus 4, it'll be the following, and then the next, and the next, and the next. So we're looking for the 32nd. Let's make use of this equation. So a sub n will represent the number that I'm looking for. I'm looking for the 32nd term. Is equal to the first value, which is 1, plus the common difference, which is 4, times, I'm looking for the 32nd value, minus 1. So first thing to do, you can simplify the value in the parentheses, so you get 1 plus 4 times 31. And simplify this. So 4 times 31, that's going to be 1. You're going to get 1 plus 4 times 30, that's 120, plus 1, that's 124. Plus 1, that will give you 125. So the 32nd term, it's 125. If you were to look now for the 14th term, so I'm looking for the 14, that'll be a sub 14. That'll be equals to a sub 1, which is 1, plus the common difference, which is 4, times 14 minus 1. Simplify whatever's in the parentheses, so you get 1 plus 4 times 13. That's equals to 1 plus 52 equals 53. So 53 is the 14th term and 125 is the 32nd term. So this is all you do with arithmetic sequences. Identify the first value, identify the value you're looking for, and identify the common difference. Same here. First value, 34. Values that I'm looking for the 18th, I'm looking for the 52nd, and the common difference. What do I add to 34 to get 31? what do I add to 21 to get 28? So, well, plus 34 gives me 31, that's negative 3. 34 minus 3, 31. 31 minus 3, 28. 28 minus 3, 25. So here D is negative 3. A sub 1, my first term, is 34, and N will be 18 for the first problem, and N will be 52 for the second problem. And just put these values into this equation, or this equation. And that's how you do arithmetic sequences.